Hi, welcome back to Tally Teaches, and today we are going to be talking about solving and graphing inequalities. So what you need to know in this type of situation is that compound inequalities are really just two separate problems that you're just going to have to graph in a different way than normal. So we're going to start with this first one. So very first thing we're going to do is just solve the problem. Solve the two separate problems. So in x plus 9 is greater than 6, we're going to subtract 9 because that's the inverse of plus 9. And we are going to get x is greater than negative 3. And we still have that or that was in between the two statements. And then we're going to do the inverse of minus 1, which is plus 1. And then I get x is less than or equal to negative 9. So this one says x is greater than negative 3. Alright, so we are going to do x is greater than negative 3. And x is less than or equal to negative 9. And now the or equal to means we need to do that. So the final statement, because this is an or problem, is you are going to include every piece of the puzzle. We're going to include everything. So we're going to put in the circle for negative 9, color it in, go to the left, and then we're going to do the circle for negative 3. And we're going to go to the right. And that, my friends, is the final answer for this inequality. Later you're going to learn some different ways to write that answer, but we're not really worried about that right now. The next one is going to be an AND statement, which you guys remember is an intersection. So we're going to solve the two separate problems. We're going to add 2, which gets rid of that minus 2. We still have the word and we do the inverse of dividing by 7, which is times 7. So now we're going to work with x is less than or equal to 5 and x is greater than negative 35. So we're going to draw those two separate things and then see what intersection, what do they have in common. So we're going to do x is less than or equal to 5, which would be about right here. And color it in that right there. And we're going to do x is greater than negative 35, which is about here. We'll go this way. So the solution is going to be what they have in common. So where's the overlap? Notice that both of them have lines in that section right there. So that means the final answer is going to be this open circle, this closed circle, and then everything between. Sometimes you're going to get a problem that is already stated in that 3-part inequality that I mentioned in the last video. Negative 4 is less than 2x, which is also less than or equal to 16. Now you can separate them into different statements if that makes it easier for you, or you can solve it as it is. Focus your attention on the middle, 2x. What do I need to get rid of? What do I need to do the inverse of to get x completely alone? Well, 2x is understood to be 2 times x, so I'm going to divide by 2 in order to get x by itself. So, in order to isolate the x, I'm dividing by 2, but since this is a 3-part inequality, I'm going to be dividing each part by 2. Negative 4 divided by 2 is negative 2, and 16 divided by 2 is 8. And as we discussed in the earlier video, this is actually very intuitive. You can just put the correct circle on the endpoints and color in the middle. So we're going to do that right now. Negative 2 is going to have an open circle, and 8 is going to have a closed circle. And we're going to do everything between. And that, my friends, is how you do compound inequalities when you're trying to solve them and graph them right after. So we're going to be talking about absolute value equations and inequalities in the next set of videos. That's it for today.